that go on? Okay. So we're going to continue with linear equations today, just adding a little bit more. So if two lines are parallel, so we talked about slope as like the steepness of the line, and I said if two lines were parallel, what is it that we know about the slope? So parallel lines have the same slope. And I said if you like held a pencil on one line and you wanted to move it to the other line, it's like the same steepness. Like if you were climbing up the hill, this line is no steeper than that line. And what did we say if a line is, say, steeper than another line? What do we know about the slope? Which one's larger and which one's smaller than each other? So these are not the same slope. This one is not very steep, and that would be much harder to climb up, right? So they're different slopes. What do we know about those ones? Which one is the bigger number? The top or the bottom? The top one. The steeper the slope, the bigger the number. So this is a larger value, and this one is smaller. And if these are equal slopes. So parallel lines have no intersection point. They don't cross. So if I said show that the following lines are parallel, what's that asking you to do? So you say parallel lines have equal slopes, so whatever she's going to write down, I have to show that the two lines have equal slopes somehow. So here's our two lines. They're not in y equals mx plus b form that we saw last class, so you can't just read the number off in front of the x and say that's the slope. They have to be in the right form to read the number in front of the x to know what the slope is. So these are not in the right form right now. How do we put them in the right form? I have to adjust. So we're going to write them in mx plus b form, and then we can read in front of the x. If they're both the same, then they are parallel, and if they're different, then they're not parallel. So take our first line, 2x minus y plus 3 equals 0. So to get it in this form, we need the y by itself on one side, everything else on the other side. Now this y is negative. We don't want a negative in front of it either. So if we left that and moved everything over, we can't have a negative in front of the y, nothing in front of the y, just a 1. So how do you get rid of the negative? Yeah, you can, and whenever you can divide everything by negative, or you can just change all the signs. As long as there's an equal sign, you're allowed doing that. Or divide everything by -1. And we will get y equals 2x plus 3. Change all the signs, basically. Yeah, you could absolutely, and I would do that. So she asked if you could bring the y to the other side, and it would be positive, and that is probably what I would have done. But I said way long ago that I try to always in class bring it to the left, whatever you're solving for, and then showing you how to do that, because you always end up with something like that. And I don't want to change up my method too much. So this slope is what? 2. So that's for line 1. Now we just have to do the same thing with line 2. So here we would have, so this is line 1. Line 2, 6x minus 3y minus 3 equals 0. So I have the minus 3y. What do I need to do to each? Divide by negative 3. So divide everything by negative 3. So that will be y equals positive 2x. 3 over 3 is 1 minus 1. Okay, so both slopes are 2, so the lines are parallel. That would be it. If they weren't 2, you would say they're not. But let me tell you something about the way I worded the question. People miss this sometimes. The question said, show that the lines are parallel. So if you got 2 different slopes, you probably did something wrong because you're trying to show that they are parallel. How could I word it so that the answer could be they're not parallel? Right. Are the 2 lines parallel? Right? Then I'm not telling you the answer. But by saying show that they are, that's very common in math to say show that something is true. And a lot of times people will then conclude they're not. But that can't be because we already told you they were in the question, so be careful for that. Right? So this said show that they are parallel, so you already know they're parallel, now you just need to show it. Whereas the question, are they parallel, could have either answer. Okay, what about perpendicular? They have what's called negative reciprocal slopes. Reciprocal means flip the fraction over. Negative means the opposite sign. It doesn't mean that the second one is negative. So, for example, if we had 2 lines, what type of slope is this? Negative or positive? Negative. For the other line to be perpendicular to it, that's me at a right angle, it has to be the opposite sign. Right? If one goes down, the other one has to go up. So they have negatives, or the different sign from each other. This would be a negative slope. And this one is a positive slope. So they have different signs from each other. And what it works out to be, these are about the same steepness, wouldn't you say? This one might be slightly steeper than the other. It's hard to tell if you have to flip it. Right? You need graph paper to see that. But let me show you another. So if we had one that's not very steep. So what kind of slopes are not very steep? What would the number be like? A fraction, right? So if you have an x and y axis and it goes right through the center, that's a slope of 1. So anything down here is going to be a fraction slope. And anything up here is bigger than 1. 1 is right in the center, okay? So if you see a line that maybe is, so here's the ground, or the x and y axis, say. This one is not in, doesn't cut it in half, so it's not a slope of 1. It's a fraction. And then if I made the perpendicular line to that, is that also a fraction? No, it's steeper than 1, isn't it? So what happens is, say this one is -2. This, to be perpendicular, has to be positive 1/2. So if we flip over the fraction 1/2, you get 2. So it works that way all the time. If their lines are perpendicular, they're actually just the reciprocal of each other. So it's like the number flipped over, but the sign has to be different. Okay? So if I said find the slope that is perpendicular to the slope of the line (3 over 4 x plus 5). So what would we do? We'd say, well, this line has a slope of what? 3 over 4. So a perpendicular slope would be, flip the fraction over, 4 over 3, but change the sign. So if that one's positive, this would have to be negative. Negative 4 over 3. So that is the slope that is perpendicular to the slope of this line. These are more than one. Like if we were to draw this line, let's draw it. Okay, so let's draw that line, the one that I'm given. Let's graph it. So let's graph that line and any line that's perpendicular to it. Is there more than one line perpendicular to it? Or is there just one possibility? Okay. How do we graph a line, first of all? What do we need to do to graph a line? 2 points. Now, if you're given the equation, you can read 1 point right off the equation. What point is that? So we need 2 points to graph. One of them is the y-intercept that you can read right off of the graph. That's when x is 0, y is 5. If you don't remember that, just plug in 0 and you'll get y is 5. We need a second point. A good one would be the x-intercept, but it's not the only one. You could find any point. Remember I said an equation actually holds an infinite number of points? So you could really plug in anything. But if you're graphing it and something else, it is good to have the intercepts. So this one is the y-intercept, right? That's because x is 0. So what if we want to find the x-intercept? That's when y equals 0. What do we do first to solve that? Move the 5 over, because you need to isolate wherever the x is. So move the 5. Now this is a fraction equals a number, so we can cross multiply. Multiply the 4 up here. So 4 times 5 is 20. And now divide both sides by 3. So we get negative 20 over 3 as our x value, and our y value is 0. What's negative? Now I said mixed numbers are, we don't write them in mixed numbers, and I didn't. But I said mixed numbers are only good for graphing, to know where it lies between. So how many times does 3 go into 20? 3 times 18, 3 times 6 is 18, so 6 times. And how many would be left? 2/3. So 6 and 2/3, we're never going to write that down in calculus. But it's good for graphing, right? So that's why mixed numbers are important to learn, but they're not really something you'll want to write down, 6 and 2/3. You'll write it as that. Okay, so let's graph this. So x is minus 6, so we need to go to 7. And the other point was 0, 5. So 0, 5. 1, 2, 3, 4, 5, 6, and 2/3. So this line has a positive slope, 3/4. It's going up. It's not as steep as 1. It's not right in the middle. It's a little shallower. It goes through 5 on the graph. That's the y-intercept. We found the x-intercept over here. Now, if we wanted a line, it just said and a line perpendicular to it. My question, and I didn't really answer or wait for an answer, was, is there more than one possible answer? Yeah, here's a line perpendicular to it. Could there be another? Another? Could everyone in the class write a different one? Yeah, you probably wouldn't. The chances are not, but let me show you how to make up one. So we need a line perpendicular to it. So we know the slope of this line is 3/4, so the perpendicular slope is -4/3. So we need to put -4/3 in front of the x in an equation. So what would that look like? Y equals -4/3x, and what could I put here? Plus anything. So pick a number. 7. 7's not on my graph, but sure. That makes it tricky. So 7's up here. So the y-intercept is 7, and the line is perpendicular. There it is. So y equals -4/3x plus 7. Let's pick a different one. 0, sure. So it goes through here. So that would look like y equals -4/3x plus nothing. And I'm guessing what perpendicular looks like to that. Any line. And wherever it hits, like if this was y equals -4/3x, where does that look like it hits? Let's say 1, 2, 3, 4, 5, 6, 7, say 8, -8, right? So you can put the intercept on and draw the line. And they're all parallel to each other, right? Because they all have a slope of -4/3, but any of these could be a line perpendicular to that line. And everyone in the class could pick a different one, although most of you would probably pick 1 or 0, something that you could draw easy on it. Maybe 7. You probably wouldn't draw 100, because then you'd have to make your graph a lot bigger, and it would be way out here. So most likely you'd pick something in this area that you could draw easily. Okay, so let's do 2 questions, one with parallel and perpendicular. So find the equation of the line find the equation of the line through the point 1, 3 and parallel to that line. So to do an equation of the line, we need to fill in y minus y1 is m onto x minus x1. And we need two things. We need a slope and a point. We plug those in. We leave these x and y alone. So we leave those alone. We plug everything else in, and that will give us our equation of the line. So what were we given in the question? 1, 3, the point, 1, 3. So we have the point, and how do we find the slope? The slope is parallel to this line, so we need to rearrange it and read off the slope, because it would be the same slope since it's parallel. So we want the slope of the line 2x minus 4y equals 8. So rearrange that. We don't want the minus 4 in front of the y. So divide everything by minus 4. That's all three things. So y equals, this is a positive 2 over 4. What's 2 over 4 reduced? So the slope we want to use is a half. If you use 2 over 4, it would still work. It's just numbers are a bit bigger, but 2 and 4 are okay. So even if you forgot to reduce the fraction, it would work. So we want this slope and the 0.13. And we plug them in. Multiply that half by each of these. 1 times a half is a half. And then bring the 3 over. Minus 1/2 plus 3 is minus 1/2 plus, multiply that by 2. 6 over 2, which is 5 over 2. Or 2.5 if you want. But again, we don't usually use decimals. If you put 2.5, it's not wrong. Like 3 minus a half is 2.5. Where it becomes wrong is if it was like, say, a third, and you want to put 0.33, but it's really 0.333 forever, and by rounding it off, it's no longer correct. It's now an estimate. Anytime you round off a number, it's not correct anymore in calculus. You have to leave it as a fraction. That holds all the decimals. 2.5, you're not rounding that off. It's 2.5. It ends. So 2.5 is equal to 5 over 2. But say 1/3 is not equal to 0.33, no matter how many 3's you write down, it's not right. You're estimating by rounding something off. So that is not equal to that, it's close to that. And so you have to leave it as a third, or you can use, just for graphing purposes, a rounded off number. But remember, it's not equal, it's sort of close to that. Okay? Anytime you round off a number, it's no longer accurate. A fraction is always accurate. Okay? That's why it's better to put everything as a fraction. Okay, so there is a line. It has the same slope as the line given in the question, a different y-intercept. I'm just going to draw a little tiny graph here. This is 2.5 y. Slope is a half. Which way is that going to go? Up. And not right about here, maybe. I'm just taking a guess. To do it totally correct, you'd put another point. And the other line up here, what was the y-intercept? -2. So this one was 2.5 and the other one was down here. But they're the same steepness. They both have the same slope. To actually draw them accurately, you would find a second point they don't look totally parallel, but they're supposed to be. If they don't, because what would happen? What's going to happen if I keep drawing this? They're going to get closer and closer to each other and they're going to cross, so they're not parallel, but they should. See if yours looks parallel. There, might be a bit better. Okay. So what if we had a similar question, but it said perpendicular? What do we do? So find the equation of line through a point and perpendicular to. So this question says, find the equation of the line through the origin and perpendicular to 5x minus 2y equals 6. B, graph both lines. So we'll do it accurately because it would actually ask to graph. So we'll have 2 points that we connect it to. And C, find the intersection point, which is what? What is the intersection point? Not the intercepts, but the intersection point. Like an intersection on the street is where two streets cross. So it's the point where they cross. This is the point. I can't ask that with parallel lines because there is no point where they cross, right? Okay. So, solution. What's the origin? 0, 0. So the point they're giving us to go through is 0, 0. And we want to be perpendicular to that line, so we need to find the slope of that line. So we need to rearrange it. Divide everything by -2. 5 over 2, x minus 6 over 2 is 3. So here is line 1. Let's call it A, capital A, because I'll label it on the graph later. So there's line A. The slope of that line is 5 over 2. The y-intercept, because we'll need it later to graph it, -3. So that line has a slope 5 over 2. We want the perpendicular slope. So flip it over and change the sign. So -2 over 5. So we have our point. We now have our slope. And we plug them in. So y minus 0, minus 2 over 5, x minus 0. X minus 0 is x, y minus 0 is y. There's our line. Anytime you see a line like this, it goes through 0, because the y-intercept's missing, so that means 0. So this is part A, asked for the equation of the line. Now part B asks us to graph. So line A we need 2 points. So to graph both of these lines, we'll need 2 points on each of the lines. So 1 point is always given if you've got the equation, because you can read it off the -3. And how do we find a second point? You can plug in any number you want for x, but it's best to find the other intercept so your graph is crossing the axis in the right place. So this is where x is 0. We need to find the point where y is 0. So let's plug in 0. Bring the 3 over. Then what? Cross multiply. So 6 equals 5x, and then divide both by 5. So x is 6 over 5. So there's 2 points for line A. Line B was y equals -2 over 5x. So the point that's the intercept is given, or the y-intercept, because there's nothing added. And it said it goes through the origin, so they already gave that point anyway. This is the y-intercept, but isn't it also the x-intercept? Right, if it crosses right there, that's where it crosses both lines. So how would we find another point? We need another point. By plugging in y is 0, cross multiply, 0 equals -2x, divide both sides by -2, we just get 0, which is already the point we have. Right, so there's not anything new. So we do need another point. You can't just plot 0, 0, and then give up. So how do we find the other point? Remember, there's infinitely many choices, because that's how many points each equation holds. Plug in any value of x. Now, I want you to be smart about it. What's an easy value of x to plug in to this equation? Not just any equation. Like 1 might be an easy number to plug in and do stuff to. But what about this particular equation? What x value would be nice to have here? Not 2. 5. Why? Right, like there's a fraction with a 5 on the bottom. If I plugged in x is 5, I will get -2 over 5 times 5. The 5's cancel and I get -2, and I don't have a fraction. What would be another number that would not result in a fraction? That would make the 5 cancel? 10. Sure, 10. And then you'd get -4 because you'd have a 2 left over. Any multiple of 5 actually will get rid of the 5 on the bottom. You don't need to plug that in. You could plug in any number. You could plug in a 1 and then you'd get -2/5. But then you have to plot -2/5 as a point, right? So okay, so line A is 0 and -3. And 6 over 5, 0. And line B, 0, 0, and 5 -2. So I just need to make my graph so that those points fit. 0, -3 on the y. So 6 over 5. How many times does 5 go into 6? Once. So it's just a little bigger than 1. And we're going up to 5. The other y value is -2. So that's really all we need on our graph. So line A, 0, -3. And 6 over 5 is a little bigger than 1. There's line A. Line B, 0, 0. and 5, 1, 2, 3, 4, 5, negative 2. Hopefully yours looks perpendicular. Oh, I missed the point, but there it is. And that sort of looks perpendicular. We'll see how accurate my graph is without graph paper in a second. Because we're going to find the intersection point. And whenever you find the intersection point, I always say, look back at your graph and see if it looks okay. You might want to fix your graph up if you kind of messed it up. A little ruler would be good to have. All right, I'm going to try to add one to my... If you measure these tick marks or just eyeball them, that makes a difference sometimes. Okay, and I labeled them. And I said that anytime you have more than one line or one graph on the same diagram, you should label each line. Okay. And these can have arrows on the end. That's more accurate to do that. Okay, so how do we find the intersection point? If you drew this on a computer or a graphing calculator, you probably played with those in high school, you can actually move the little cursor right to the point where they cross and read it. So that's not a good way to do it today, because I don't know if that point, it looks like 1 and negative a half. That would be my guess by my graph. Does anyone else have a different one by their graph? It could be very different because we probably didn't use a ruler. If someone used a graph paper and actually counted and everything was even, yours might be more accurate than mine is. Right? Did anyone use graph paper? Yeah, can you see what your point looks like?
It looks like a bit less than 1 on the...
Here? Like down here?
Yeah, a bit
yeah.
less than negative 1.
And then how far over here?
Just a bit past 1.
Yeah, so mine looks like it's just at 1, but it could be. His looks slightly over here. Right? Okay, so we'll see how accurate mine is, and maybe yours looks totally different than mine. Is anyone's like up above or something? Shouldn't be, because you plugged it in 0 and you went down, so it shouldn't be. Should be down, but it might be like way down or something. Okay, so how do we find the intersection point? So what we're going to do is called the substitution method. We're going to do 2 different methods, the other one next class. So the substitution method is when you have 2 equations that are in y equals mx plus b form. You can use this method always. What is our other line? There. Okay, so these ones we already have them in y equals mx plus b form. So to find the intersection point, we're going to set them equal to each other. Y equals y. Because we're trying to find the point that's the same, so we want the 2 equations to be equal. So minus 2 over 5x equals 5 over 2x minus 3. And then we solve that equation. Just going back to like section 1.1, solving a linear equation. Now this has little fractions in it. So there's different ways we can do this. Move all the x's to one side. So minus 2 over 5x minus 5 over 2x equals minus 3. I don't like all those negatives. What can you do if you've got something like that? Change all the signs. You can always do that whenever there's an equal sign. So 2 over 5, or divide everything by negative 1. There, that looks a little better. So what next? 2 options. The one I did most often is what? How do you get these together? Common denominator. So the common denominator would be 10, so we need to multiply this one by 2, and this one by 5. So we'll have 4 over 10 and 25 over 10. 4x plus 25x. Now what? Cross multiply. So 29x equals 30. Does that reduce? You never need to think about it. If they're 1 apart, they never reduce. Okay, there's nothing that, they have to be 2 apart for a 2 to go into it. They have to be 3 apart for a 3 to go into it. The only thing that goes into numbers that are 1 apart is 1, and that doesn't make you reduce it. So there's the x value. That's pretty close to 1. Is it a little above 1 or a little below 1? A little above. Mine, I think, looked, if I look really close, I can pretend it's above by that much, right? There we go. Okay. Now, how do you get the y value? You plug that into either equation, because we made them equal, so the y values are equal because we set them equal. So the next step would be to plug this into either equation. And solve for y. Which equation is going to be easier to plug into? Just this one, because then we don't have that plus a number. We just put it in and we have our answer. We wouldn't need to do a common denominator. But both will give you the same answer. So 30 over 29. Not very nice. 5 times 29. You can do 5 times 30 and get 150. And how much less is it? 1 less off of each of those, so 145. Does this reduce? It does. By 5 for sure, right? This is 5 times 12, and this is 5 times, don't think too hard. We had it already? I said, don't think too hard. We already had it was 5 times 29, right? Does that reduce? No, nothing goes into 29. So, but you could think about it for a while if you wanted, but there's only so many options. Like 12 could be 2, 3, 4, 6, and if none of those go in. Okay, so what's our intersection point? 30 over 29, comma, negative 12 over 29. Now, does that look about right on our graph? Probably. Okay, so that's actually, when you're finding the intersection point, that's section 2.3. So we started in 2.2 and we ended the question in 2.3. So what we're going to do for 2.3 on Wednesday is just do lots of intersection points, different methods.